Alright, this is the last section of the geometry review from number 81 through 100. For 81, what is the distance between negative 5, 2 and negative 9, negative 4? So again, we're finding distance now. Your distance formula, let me write that in a different color. Your distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, difference of the x's squared, difference of the y's squared, add them together, square root it, gives you a distance. Again, that formula is based off of Pythagorean theorem. Now, plugging in these points, so I'm just going to plug it in as you see there, and we'll simplify. So I'll use this one as my x1, y1, x2, y2. So I got negative 4, or actually let's do negative 9 first. Negative 9 minus negative 5, so that becomes plus 5 squared, plus negative 4 minus 2 squared. Negative 9 plus 5 is negative 4. Negative 4 minus 2 is negative 6. Negative 4 squared becomes positive. Everything should become positive at this point. So 16 plus 36. 16 plus 36 is the square root of 52. Now, you can go two ways from here. You could either find a decimal or simplify a radical. I think it's more important for this semester to know how to round it. So let's round this off to the hundredth place. The square root of 52, we're going to do square root of 52. You can just plug that into the calculator. Gives you 7.21. Or, if you did want to simplify a radical instead, square root of 52, well, the biggest perfect square that goes into 52 is 4. So we could split this into 4 and 13. 13 is a prime number, so we can't factor that anymore. The square root of 4 is 2, so that comes out. 13 stays under, so it's 2 radical 13. So again, either one of these would work as an answer. Now, it just depends what the directions are and how they want you to round it, or what the options are on the test for multiple choice. Because remember, the exam is multiple choice. So you shouldn't have to guess as to if they want it rounded or if they want it as a radical. Now, if they do want it as a decimal, make sure you follow whatever directions they have for rounding. So if they say round to the 10th place, that's 1 decimal place. It says round to the 100th place, that's 2 decimal places. Alright, so 82. If AB has endpoint A there and midpoint there, then give the coordinates of AB. Now, you could use the midpoint formula if you want to. I'll write that out here. Midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Essentially, the midpoint is found by doing the average of the x's, average of the y's. Now, if you're to do this problem, we already have the midpoint. So the thing that makes it a little bit complicated is you'd be plugging in an x value, you'd be plugging in a y value, you'd still have 1 x and 1 y left, you'd be dividing by 2, and you'd have to set it equal to these. So, for example, if you wanted to solve it using an equation, you would have x, and it doesn't matter which one you plug this in for, so I like plugging it in for the second one, plus 2 divided by 2 equals 10. And it'd have y plus 13 divided by 2 equals negative 1. And we'd have to solve for each one separate. So if we solved for this, we'd bring 2 over, it'd be 20. So you'd have x plus 2 equals 20. Subtract 2, x equals 18. On this side, bring the 2 over by multiplying it. So y plus 13 equals negative 2. Subtract 13, and you get negative 15. So you have your coordinate at 18, negative 15. Now, I think that way is a little bit confusing. What I like to do is what I refer to as the snowman method. The midpoint is exactly in the middle. So if you set this up, so you have 3 coordinates, it looks kind of like a snowman stacked on top of each other. You have 3 different coordinate points. The 2 on the ends are the midpoints. Sorry, the 2 on the ends are the endpoints. The one in the middle is the midpoint. So plug these values in. You have 2. You have 13. The midpoint, 10, and negative 1. Well, the midpoint is exactly in the middle of the 2 points. So if you look to see how far did we go to go from 2 to 10, what's the difference there? Well, we went positive 8 units, so plus 8. So add 8 more, and we're now at 18. Here, to get from 13 to negative 1, well, we subtracted 14, so minus 14. So subtract 14 more. Negative 1 minus 14 is negative 15. Again, 18, negative 15 is my answer. Same as what I got up there. But again, I think this is much easier, a lot less work. Number 83. This is a proof, and they want you to do the entire proof. You don't have to use every single one of those boxes. In fact, you probably only have to use about 7 of those boxes. But you kind of need a little bit of a game plan as to what are you going to have to do in order to prove that we have parallel lines. So, what they give us to start off, we have the fact that AD is parallel to BC. So let me go ahead and write that down as my first given. AD is parallel to BC. Reason? Simply given. Then, based off of this statement, we can say something. Anytime we are given parallel lines, we should be able to say something about the angles. Well, the only angles that relate to these 2 parallel lines would be this one and this one. We can mark those 2 as congruent because those are alternate interior angles. So what's my next step? ADB, angle ADB is congruent to angle CBD. CBD. Why? Alternate interior angle theorem. Right. Now, don't really know anything else from that, so let's go ahead and list our other given. We have AD is congruent to BC. I'm going to go ahead and mark that. AD is congruent to BC. AD congruent to BC. And that's given. So, we have our 2 given statements now. We don't really know anything else because of that. However, we have 2 things marked as congruent right now. Well, we have this diagonal in there, which is actually separating this into 2 triangles. And if I know 2 things are congruent about those 2 triangles, I can't quite say that the triangles are congruent. But if I can find one more thing congruent about those 2 triangles, then the triangles have to be congruent. And maybe I can use that to prove we have parallel lines. So let's see. Right now, both those triangles share a common side. They share the middle. So that line segment BD is congruent in both of them. So I'm going to say that BD is congruent to itself, BD. Why? That's what we call the reflexive property. And it's property of congruency, so I'm just going to say POC. Now, we have 3 parts in both triangles. Once we have 3 parts, we're able to say the triangles are congruent. So let's go ahead and state that these triangles are congruent. We have triangle, it doesn't matter what order you state the first one in, but whatever order you do the first one, you have to make sure you follow a corresponding order for the second one. So triangle ADB is congruent to triangle CBD. So triangle ADB is congruent to triangle CBD. Why? Well, again, we have three parts. What three parts are they? We have two sides and an include angle. So side, angle, side. Side, angle, side, congruency, and you can call it either a theorem or criteria. At this point, I can't remember which one our book uses, but they're pretty much interchangeable. Some books call it a theorem, some say it's criteria. Now, once we know the triangles are congruent, all the other parts of the triangles must be congruent, so all the corresponding parts. So the next part of this, I'm going to be able to say that all the other parts are congruent by CPCTC. Now, what part do I need to know in order to say that I'm trying to prove they're parallel? So into this point, I just kind of went with the flow of what they gave me. I realized, hey, I could actually get these triangles congruent, so I made the triangles congruent. Now that I know the triangles are congruent, I can set up all sorts of different things, all sorts of statements that could be written here. However, there's only one that really helps me prove the triangles are congruent. Well, to start this off, they gave me a set of parallel lines. And when I had the set of parallel lines, I said the alternate interior angles are congruent. Well, if I knew the alternate interior angles were congruent for the other set of lines, then I could say these are parallel. So these two, I'm going to say, are congruent because of CPCTC. So angle ABD is congruent to angle CDB because of CPCTC. Again, those are alternate interior angles. So since the alternate interior angles are congruent, that means that these two lines must be parallel. So that's saying it in the reverse order of AIA theorem, right? Alternate interior angle theorem. Alternate interior angle theorem says if you have two parallel lines, then the alternate interior angles are congruent. Well, now we're saying we have alternate interior angles congruent, therefore the lines are parallel. So that is the opposite. We're switching the if and then. It's our converse of AIA. Converse of alternate interior angle theorem. And again, that's our final proof statement. AB is parallel to CD. So that's our whole proof. Now, if we really wanted to make this short, we could. Again, the test is all multiple choice, so you'll have to look and see what they give you. There is one option where we could have done this in almost no steps. They gave us these couple givens. These two givens I left marked in red, so you could see them. So see the two things marked in red? We actually have a property that says if the opposite sides of a quadrilateral are both parallel and congruent, it is a parallelogram. So if we wanted to do this in just 4 steps, we could. We could have listed our two givens. Our third step could have been the fact that we have a parallelogram, and there wasn't a name for this theorem, so you would have had to write it out, so there's not really a lot of room to write the entire theorem out there. Because again, when a theorem doesn't have a name, you could state the entire fact. But if a quadrilateral has opposite sides both parallel and congruent, it must be a parallelogram. So we could have said for the third step, it's a parallelogram. Because if a quadrilateral has opposite sides parallel and congruent, it is a parallelogram. Then, once you knew it was a parallelogram, by definition, the opposite sides would be parallel. So that would be our step 4. And it would be definition of a parallelogram for a reason. So there's more than one way that you can do this. Again, this is probably the way most people went, but there are other options. All right, number 84. Consider triangle ABC has been transformed through rigid motion, and its image is compared to triangle XYZ. Determine if the given information is sufficient to draw and provide conclusion. Explain your answer. So, on here, let's look at how they have this matched up. A and X, B and Y, C and Z. So we have all three angles. Can we use all three angles to prove that they are congruent? Nope. That could prove similarity, not congruency. That first one is false. On the next one, you have angle A and angle X. All right, they match those up correctly. B and Y, they match them up correctly. And then BC and YZ, they match those up correctly. So we have two angles and a side. Now, no matter how we have that, I don't even have to look to see if the side is between the angles, because it's not asking us, are we using angle, angle, side, or angle, side, angle. Both of those things work. If we have two angles and a side, no matter what, it'll fit one of those two theorems. So this is definitely going to give us congruent triangles. All right. On the next one, we have an angle, so A and X. Then we have AB and XY, BC and YZ. All right, so we have three congruent parts matched up correctly. But now, that's two sides and an angle. So, if we have two sides and an included angle, this works. If we have two sides and a non-included angle, that doesn't work. So, it's important to see which pieces we have. So I'm just going to draw one of the two triangles. I don't need to draw both of them, because I can already tell that they're matched up correctly based off of the statement. But I need to look at a triangle. So I have angle A. That's one of the things we're saying is congruent. We have side AB, and we have side BC. Well, that's two sides and a non-included angle. And ASS does not work. So that is false. The only time that would work is if we had a right angle. It doesn't say anything about a right angle, so this cannot be hypotenuse leg. So again, first one and last one are false, middle one is true. Alright, on the next set. So, identify the congruent relationships with a check mark. And then 86 says, identify the supplementary relationships with a check mark. Notice, all the same things in the exact same order. So we can kind of do these together. Base angles of an isosceles triangle. Well, base angles of an isosceles triangle are congruent, so that one gets a check over here. Corresponding angles formed by transversal intersecting parallel lines. Again, those are congruent, so that one gets a check. Diagonals of a rectangle. Those are congruent, it gets a check. Diagonals of an isosceles trapezoid. That also gets a check. So far everything's been congruent up through A through D. E, vertical angles. Also congruent, so that also gets a check. Linear pair. Linear pair is not congruent, they are supplementary. So on 86, linear pairs would get a check. On G, alternate interior angles formed by a transversal intersecting parallel lines. Alternate interior angles are congruent. We just used that a little while ago on the one above. Opposite angles of a parallelogram. Those are also congruent. Consecutive angles of a parallelogram. Consecutive angles are supplementary, because in a parallelogram, if the parallelogram is not a rectangle or a square, then you have one obtuse and one acute. Those wouldn't be supplementary. They wouldn't be congruent if you had one acute and one obtuse. They'd have to be supplementary again. And you can think of this as consecutive interior angles or same side interior angles when dealing with parallel lines. So most of the checks were over here on 85. You had A, B, C, D, E, G, and H, and then 86 was only F and I. Okay, over on 87. Now we have the mid-segment of a trapezoid. When we do the mid-segment of a trapezoid, the mid-segment is going to be the average of the two bases. So, you could set this up as an equation. So I have 20 is the middle one, and x is the bottom one. So if I set this up as an equation, now I'm not saying you have to, so I'm going to show this two different ways. 32 plus x over 2 equals 20. Because again, we know that this is 32, we know that this is x, and we know that this is 20. That's what they're giving us. So multiply by 2, if you have it set up as an equation, and you get 40. Subtract 32, and x is 8. Now, there is another way of doing this, and it's kind of nice because over here I talked about snowman method. Well, right here next to it, this is kind of the same idea, because remember, what is the midpoint? It's the average of the two endpoints. What's the mid-segment? It's the average of the two bases. So that same idea that we used over here for snowman method, we could also use here, since they gave us the middle value. The difference between these was 12. So then go negative 12 more, and you get to 8. So x is 8. Again, it's that same concept as what I did for the snowman method. We have the middle number, which is the average. The average is directly in the middle of the two numbers. So the same distance from one number to that middle number has to be true for the middle number to the next number. So just make sure you're going in the same direction though. On B, now this gives us the two ends. So plugging it into our formula for an average is easier here. We're just adding the two numbers, dividing by 2. So again, we know that this one is 20. Different color for this one. So this is 20. This is 42. We're going to average them. So what's right in the middle? So 20 plus 42 divided by 2. 20 plus 42 is 62. 62 divided by 2 is 31. 31 is the correct answer there. All right, on C. Again, this is another average problem because they gave us the top number is 22, the bottom number is 42. I don't know why they would have picked numbers so similar to that one, but they did. So 22 plus 42 divided by 2. 22 plus 42 is going to be 64. 64 divided by 2 is 32. All right. On 88. Rectangle RSUT has diagonals that meet at point X. So, things that we should know about these diagonals. They're congruent and bisecting. RX is 4X. ST, this entire length, is 100. So that means each of these would be 50. XU is 5Y. Solve for X and Y. Well, if all these have to be 50, we're simply saying 4x equal to 50 and 5y equal to 50. For x, divide by 4, and 50 divided by 4, that's not going to give us a whole number. It's 12.5. 50 divided by 5, that will give us a whole number. That's just 10. All right, 89. We're back to a mid-segment. So, on this one, this was kind of hard to read, so I rewrote over it a little bit. But we had 6 at the top, 4x plus 8 there in the middle, and 9x plus 5. This one we really have to do using our formula because we don't have whole numbers for each of these. So, average the top and bottom, it should equal the middle. So 6 plus 9x plus 5 equals 4x plus 8. First thing, combine like terms on this side, 9x plus 11. Now we're going to have to take values across to the equal sign, so we're doing opposite operations to move these. So minus 4x from both sides. Bring the 11 the opposite way. So I got my variables are coming to the left side. My constants are coming over here to the right side. 9x minus 4x is 5x. 8 minus 11 is going to be 3. Did I do something wrong? No, I'm getting negative 3. Let's double check these values here. Something seems off to me. We had 6 is equal to 9x plus 5 equal to 4x plus 8. I brought 4 across by subtracting it, gives us 5x. This was 11, brought 11 across by subtracting it, that gave me negative. I'm thinking one of my signs here is wrong, because that would not make sense. I'll have to come back to that one at the end because something's wrong with my numbers. I'm not sure what it is. I'll go and check the original review in just a minute. On 90, find the measures of the number angles in the isosceles trapezoid. So, if this is 68, this one's also 68. If those are 68, these are supplementary, so subtract 68 from 180, and you're left with 112. That's 112. That's also 112. So we have 68, 68, 112, and 112. On number 91, given kite ABCD, in which AN is 2.9, they have it labeled. What is AC? Well, this one's bisected, so we're just doubling that. 2.9 times 2 is going to give us 5.8. 92. There's a lot of congruent parts here. So this one's bisecting these angles. So angles 5 and 6 are going to be the same as what's next to them. So 5 is 43. 6 is 37. These angles right here, 1, 2, 3, and 4, those are all 90. Now, these two angles are going to be congruent, and these two angles are going to be congruent. So let's use one of our triangles here to figure out the missing value. So if this is 90, we can figure out 10 by doing 180 minus 90 plus 43. So that'd be 180 minus 133. So that'd be 47. So angle 10 is 47. And angle 8 would also be 47. Then we have, for angle 9, do the same thing on the opposite side. So we have, this is 90, 180 minus 37 plus 90. 3790 is 127. So that's going to be 53. So we're going to have 53 for both 7 and 9. So final answers there. I know it's a little off the screen. First four were 90, followed by 43, followed by 37, 53, 47, 53, 47. And that's it. On the back, not a whole lot here. 93. If AC equals 72, then solve for the length of BC. So we have the whole thing is 72. So these two together have to equal 72. So add those two. 2x and 5x is 7x. 3 and negative 8 is negative 5. Add 5 to this side, you get 77. Divide by 7, you get 11. X is 11, but we want BC. So we got to plug 11 back into this side. 5 times 11 minus 8. That's 55 minus 8, which is 47. And that'd be our answer. On the next one, we're just solving for x. These two are congruent because they're vertical angles, so the two equations equal. Oops, this was 3x. Bring the 2 across this way, so subtract 2x. Subtract 2x. Easy with x. Subtract the 10, going the other way. That leaves you with 5. Again, that's it. X equals 5. On this one, same thing. Here, we are going to set those two equal. X minus 125 equals 2x plus 39. Again, they're vertical angles. Subtract 2x, you get 4x. Add the 125 to the other side. 125 plus 39 is going to give us 164. 164 divided by 4 is going to give us 41. That's not the final answer. This one asks us to actually plug in and solve for A, B, C. They want this angle over here. So it doesn't matter which one we plug into, because at the end we're going to have to subtract from 180 because we have a linear pair with either one of those angles. So plug 41 in. I'm going to use the smaller numbers. So if I do 2 times 41 plus 39, 2 times 41 plus 39, that gives us 121. So that's, these two angles are both 121. Subtract that from 180, and we're left with 59. And that'd be our final answer. 96. Ray AB bisects CAT. So they give us CAT, which is the entire angle. This is only half the angle. If you want to draw a diagram, that might help. So over here, I'm just going to draw it real fast. CAT, there's B. Again, you can see CAT is the full thing. CAB is only half. So you could either divide the whole by 2 and set equal to this, or multiply this one by 2 and set equal to that. I'm just going to split this one in half. So each angle is 15. So 15 equals 2x plus 10. Subtract 10, you get 5. Divide by 2, and you get 2.5 for x. This is essentially the same exact figure, but they used a few more expressions there. So again, I'm going to go ahead and split this one in half. So 4x minus 15 equals 2x plus 10. Bring the 2x over by subtracting, you get 2x. Bring the 15 over by adding, you get 25. Divide by 2, and you get 12.5. All right, one interior angle, one exterior angle. So for one interior angle, let me write our equation over here off to the side. N minus 2 times 180 over n. For one exterior angle, it's going to be 360 divided by n. This top part, the numerator, is the sum of our interior angles. This is the sum of our exterior angles. And then we just have to divide those equations by n in order to get one interior and one exterior. The one exterior is always easier to find. So what I would do on this one, I prefer finding the exterior angle first, because then one interior and one exterior of a regular polygon have to be supplementary. So fast way of doing this one, if I just do 360 divided by 12, 360 divided by 12 is 30. We found an exterior angle. So then 180 minus 30 is 150. And that's our interior angle. Again, you'd find the same thing if you plugged into your other formula. On 99, same thing here. They gave us an interior angle, much easier to use exterior angles. So I'm actually going to subtract from 180 first. So now we know that one exterior angle is 2.4 degrees. So if I have 360 degrees and I divide by 2.4, there is a total of how many angles? 360, I hit the wrong button. I'm going to say that went bigger instead of smaller. Let's try that again. 360 divided by 2.4 is 150. Oops, that's the number of sides. That's not a degree. And then 100, find the measure of an exterior angle of a regular polygon. Again, one exterior angle of a pentagon. That's 5 sides. So 360 divided by 5. 360 divided by 5 is 72. And that will be our answer. So I'll have to look up the original things. I'll post the final answer for the one that I left off of here. My guess is one of these was actually supposed to be a negative sign. I'm not sure which one it is, so I'll have to double check the original thing. But that is the entire review from 81 through 100.